The part responsible for adding the anesthetic agent is the vaporizers. Basically, volatile anesthetic agents are used to achieve unconsciousness. As we said before, we use inhalation anesthetics, and basically such agents are exhalable and evaporate quickly, such as isoflurane and sevoflurane. The anesthetic agent vaporizers converts anesthetic agent from liquid to vapor and mixes that with the fresh gas at preset concentrations. Usually this is done by an apparatus that looks like this. Basically, we have the anesthetic agents right here, and basically on top of it, you'll find, because it can evaporate very quickly, you will find that the concentration of the anesthetic agent vapor on top of it will be almost 30%. So if we have fresh gas input and basically pass part of that into this vaporizing chamber and another part in a bypass flow, and basically we control the ratio between these two, we can actually get the concentration that we need on the other side. So basically vaporizers are primarily designed to reduce the high saturation concentration of 30%, almost 30%, to concentration required during the anesthesia, which is about 2%. Vaporizers can be implemented either mechanically or electronically. The first one, which is the mechanical vaporizer, relies on a mechanical device that does not require any power, and basically takes the input fresh gas and divides it between a bypass path and a path that goes over the inhalation anesthetic, as we said before. So basically, the part that goes right here basically gets a high concentration of inhalation anesthetic vapor, and basically goes back and gets mixed with the part that goes through the bypass path. Okay, and the summation of the two will give us the concentration that we need. We can control through a very simple valve here. It looks like another needle valve where we can control from a dial over there. And basically, this controls the mixture between the bypass and the one that goes through the inhalation anesthetics. Moreover, we have here a flap, bimetallic strip, and this bimetallic strip actually changes shape based on the temperature. So basically, takes care of compensation of the temperature, because as we know, if this is placed in a high temperature, the concentration of the paper here will be higher. And if it's in a cooler temperature, the concentration here will be lower. So basically here, in cooler temperatures, it allows the flow to be a little bit more. And basically in warmer temperature, it allows the flow to be a little bit less. So whatever the temperature will be, the flow that is going through the part where the inhalation anesthetics are placed will have exactly the same concentration when it goes and mixes with the bypass part. Alternatively, electronic vaporizers do everything that the mechanical vaporizer does in electronic form. So basically, we have also here the bypass direction, and basically here, this is the part that goes through the inhalation anesthetic. But here, we control the flow of the part that goes through the inhalation anesthetics by a valve, through a valve right here. And basically, we measure the temperature, we measure the pressure, we measure everything so that we can accurately make the mixing so that the concentration output will be exactly as we desire. So this is basically an electronic form that allows exactly the same function that mechanical vaporizers does. But this one actually has to consume some power, so basically it has to have an electrical power. And also it has compensation, much more accurate compensation of temperature and pressure variations inside the vaporizer. So these are a little bit more accurate than the mechanical vaporizers.